Today I want to talk about perimeter and area and how these apply to some common shapes you'll probably see. So to start off, let's go over some basic definitions. We can look at perimeter first, and although there's probably a more textbook definition, I'm going to kind of give an intuitive one that makes a little more sense. The best way I can describe perimeter is the distance around a shape. This will all come into sense as we do examples, but we can look at a shape such as this. And then with this in mind, we could say the perimeter is all of this distance on the outside. So it's not one of any of these, but it's all of them together. And now area is a measurement for units inside a shape. That sounds a little more confusing. If you've never dealt with area, it will be a little more confusing. Totally understandable. But if you have a shape like this one, again, we would show area as this part inside of the shape. So going over these two again, perimeter is the distance on the outside of a shape, and area is the measurement on the inside of a shape. So that's how those two differ from one another. Going over some of probably the three most common shapes you'll ever see in geometry, and I'll have more videos regarding other shapes. But to start, these are a great foundation. So when we're looking at a square is a four-sided shape. So we got 1, 2, 3, 4 sides here. And the distance of one side is the distance of every single side. So say we were given the distance of this side right here, and it was 3. Then we know that this side is 3, this side is 3, and this side is 3. And you might see this represented as something like this, where each side has like one line in it. All it's saying is all the sides are the same length. So a square is a four-sided shape where all four sides are the same length. In this example, we had 3, so all sides would be 3. Rectangle is kind of similar to a square. What you're going to have is two pairs of matching side lengths. So let's say we have this one is 6 and this one is 10. Because of that, we can say because this side is 6, the opposite side is 6, and because this side is 10, the opposite side is 10. So a rectangle is a four-sided shape, and you have two pairs of equal side lengths. And also, when it comes to squares and rectangle, each of these right here will be 90-degree angles. If you're not too familiar with that, that's okay. Just something to keep in mind that these shapes automatically have right angles on the inside of every corner. A triangle is a three-sided shape, so that's slightly different. And now, depending what type of triangle you have, there's different measurements that each side can have. But let's just say this was something like 3, 3, 5. That might not even be a possible measurement, but it's just kind of something to keep in mind. That it's just three sides of a shape, and beyond that, it's nothing specific. So now, if we're going to take the perimeter and area of all of these, I mean, the square, you have one side is 3, so you do 3 plus 3 plus 3 plus 3, because you have 4 sides, and that's 12 units. Units is just a word because we're not having like inches or centimeters, we're just saying it is something. And this is perimeter right here. Now if we're going to have the area, this is something that is slightly different. So for perimeter, we add all the outside. For square, we're trying to get the inside through multiplication. So when you have a shape like a square, and I'll draw it back again down here for simplicity's sakes. Let's say we got this. And we know all side lengths are 3. Something like that. What we can do to find the inside units of this shape is multiplying the two side lengths. So 3 times 3, and that's 9 units. And because it's inside, we say squared. Not because it's a square, which that's just convenient, but we say units squared. Best way I can describe how to actually understand area is that by multiplying these two sides through each other, you're basically going to end up filling in this inside over time, because they're going by each other all the way throughout the square. First time you see area, it's going to be slightly confusing, and that's totally understandable. But when you forget about it, you're having a hard time finding it maybe, you can just think that you're taking one side and another side, and you're seeing the measurement move as both sides move with each other. So you got this side length here, and then we're trying to find this whole inside area, so we multiply this side by that side, and it kind of just captures everything in between them. So now when it comes to something like a rectangle, we do have to keep in mind it's slightly different than the square, right? So let's say we have a rectangle here, 6 by 10 rectangle. So that'll be the side lengths for a rectangle in this example. We're going to need to find that inside area here. And square is easy because you can't mess up, all sides are the same side length, but rectangles are slightly different. So since we know we need to fill up this entire area, let's pick a side. Let's say we want to start with this side right here, 6. We know to get the entire area covered, we got to take this side here. Because then when we find the area by multiplying, it's going to fill in all this space in between them because we got all that covered right there. So let's take 6 times 10, and that's 60. And we haven't set any units in specific, so we can just say units squared. Nothing more than that. And now when it comes to triangles, this is slightly different. And I want to have another video covering triangles completely, but I did want to introduce that idea. So let's say this triangle from the bottom, the base we'd call it, to the height has a height of maybe, I don't know, let's say 2.5. That could not be true, but for simplicity's sake, we're going to say that it is 2.5. So a triangle for area is slightly different. Oh, I guess we didn't do a perimeter on this, but you would just add up all these side lengths to find the perimeter. So I'll do the perimeter on the triangle really quick. We can say 3 plus 3 plus 5, that's 11 units. So all you do is just add up every single side length on the outside of the shape. Perimeter is a very simple one. Area is where it gets a little more confusing. So when it comes to the area of a triangle, we have a formula that we can follow. You take the base times the height, and then you divide all that by 2. And you might see that and be like, whoa, that's crazily different. Well, it's a little different, but once you do this enough, I mean, you probably couldn't forget it if you tried. So we're saying the bottom, the base in this case, is 5. So let's see, we got 5 as the base, which is what we're calling B right here. And then we kind of just already said that height is 2.5. Then we know we have to divide that by 2. So you can see we're still multiplying units, so you can kind of imagine that just like the other ones, how we filled in the middle area, that's what we're striving to do when it comes to triangles. It's just a little different because you can see it's not as neatly shaped as a rectangle or a square. You got areas that are kind of getting cut out here as you go. So that's why it's a little different of a formula. But we know that 5 times 2.5 is 12.5. Then we're going to divide that by 2, which is 6.25 units. And then we'd say squared. Your teacher might want you to write out squared. I'm just going to put the little 2 above the units. It says the same exact thing, and that should probably be acceptable on your test as well. But yeah, so the idea when it comes down to this is that we're still filling in this area as we multiply. We do the 2 because this has some areas that get cut out right here. Instead of it being a perfect square, right, we're losing some area, so we can't just multiply it simply. But yeah, so base, we just gonna pick a side, and you'll probably be given a height that goes from the bottom to the very top of the triangle, and that's what we call the height, because that's as tall as that shape can get. So between square, rectangle, and triangle, to start with, these are going to be the 3 shapes that you see the most, and you need to understand how to find the perimeter and area for. So let's go over just a couple of examples here, get some more practice in, maybe understand the topic just a little more. So let's say we have another square here. and I can't draw perfect, but we're going to say this is a 4 by 4 square. So we know that every single side is 4. I'll give you guys a second to think about how to get perimeter and area. I'd recommend pausing just to practice a little bit. Okay, I'm going to assume you guys probably didn't pause and just waiting for me to get to the next part. For perimeter, what we do is add up every single side, and that's for every single shape we do. So we can do 4 plus 4 plus 4 plus 4, and that's 16 units squared. Love to see that. And area is 4 times 4. So 4, well, not squared here. 4 times 4, and that's 16 units squared. When it comes to perimeter, we're just measuring the length, so it's just units. So this is something that you can find a little interesting, that sometimes when you add and you multiply, you might get the same number. And that's just kind of how sometimes the math works out, especially on squares. This is a little common. You have 4 side lengths, so it's just going to happen sometimes when you add up and multiply. What I'd say that it's still pretty important to do it both ways, especially so your teacher can understand, you know, the process, because that's what they care about the most. All right, let's look at a rectangle here. So we're going to say, let's say we got a 3 by 5 rectangle. So we got perimeter here, area here. The perimeter, and we're going to leave out some measurements here just so we can think about it a little more. So we got 3 on the short side, 5 on the long side. So we know that we have 3 and 5 already, but we can also infer, because it's a rectangle, that the opposite side of 3 will also be 3, and the opposite side of 5 will also be 5. When you add 3 and 5 plus 3 and 5, you're going to have 16 units for the perimeter. And now area, we know that we're looking to fill in this entire shape on the middle. So we have to multiply this side by that side. So area, we can do 3 times 5, and that's 15 units squared. Very important you put that squared. Squared, we're just saying that's the inside of the shape. Perimeter, it's just units because we're just measuring it. You can imagine, like, you just measure out a line. You don't say it's, 8 units squared. You say it's 8 units long, right? Okay, so let's maybe look at a triangle example. I'm going to draw us a right triangle here. And not the best, but let's say we got a 3, 4, 5 right triangle here. Now this one looks slightly different than the other one. You might be like, where's the height line? Great question. Now, if you started at the 5 as your base, you might want the height line from here. But we're given a pretty looking triangle, so we don't really have to do that. What we can look at here instead is, let's say the base is 3. Because the base is 3, we can see from the base to the very top of the triangle, that's 4. That's the height right there. Because this line right here touches all the way up to the top. So we're just going to establish that before we get going on with the problem. We can say that the perimeter is the sum of all 3 sides. So 3 plus 4 plus 5. That's going to be 12 units. Area, rather, we're going to have that slightly different equation off from earlier. And I will rewrite that out over here. We're going to have base times height, all divided by 2. So we talked about the triangle already before the example. We said that the base is 3. We said that the height from the bottom of the triangle to the very top is 4. We're going to divide that all by 2. So 3 times 4 is 12, divided by 2 is 6 units squared. So sometimes perimeter is going to be larger, sometimes perimeter might be a smaller number, but because we're measuring them in normal units and units squared, you can't really compare them. They're not necessarily the same thing. But just to keep in mind that just because your perimeter is larger doesn't mean you did the problem wrong or anything. Totally unrelated. But yeah, so that's an example of a triangle. I think we should do some more triangle examples just because they're a little tougher than other ones. So let's say we have an equilateral triangle here. An equilateral triangle is a triangle with all the same side lengths. Kind of imagine like a square, right? All equal side lengths. And then let's say that we're given a height of, I don't know, we'll do 2.6, make it really specific there. So we can pick any of these sides, but we're going to say this one because it's kind of drawn with the problem is the base. So the base, let's find the perimeter. Let's not get ahead of ourselves here. The perimeter, we can do 3 plus 3 plus 3 equals 9 units. And the area would be 3, which is the base, times 2.6, which is the height we gave, all divided by 2. So 3 times 2.6 is 7.8, divided by 2 is 3.9. And then because it's the area, we'd say that's units squared. I want to go over the idea of the area again. We can see that the area is this inside section. So we have this line, which covers the entire shape, and you're making yourself another line, which goes all the way through the top. And that's the height right there. So that's an equilateral triangle where all sides are the same side length, something you might see as you especially get a little more involved with triangles. Now let's give an example. This one is called an isosceles triangle. And that's a bit of a weird name. Don't know where that necessarily comes from. But an isosceles triangle, these two sides right here are the same length. So let's say we have 7, 7, and then this one is 4 down here. And then let's give a height of, 6.7. Very specific again. Let's first go with the perimeter. So the perimeter is just adding up every side. We have 7, 7, and 4. 7 plus 7 plus 4. And that makes 18 units in total. And area, we can see that we have a base of 4 right here. And we have a height of 6.7. And we're going to divide that by 2. So 4 times 6.7, let's see, that's going to be 24, and then 2.8, so 26.8. Divide that by 2, and what you're going to get is 13.4 units squared. And again, just explaining it so it makes a little sense. We have this side that covers the entire shape, and then the height, which goes up through the entire shape right there. So when you multiply it, it's going to give you that area, the inside section of the entire shape. And area is always under squared units. You could write out the word square next to it, or you can put the little 2 above the units. Same exact thing. So a little review just on what we did today. We have 2 things we're talking about. Perimeter. Perimeter is a distance around a shape, and that's true for every single shape. All you do is you find all the side lengths that you're given. You might have to work to find those, and then you just sum them up, add all these numbers, and that gives you the perimeter, and it's just in units. So you could have inches, centimeters, meters, yards, whatever you're measuring the shape in. Now an area is a little different. You're not measuring the outside, you're trying to measure the inside in squared units, which sounds a little confusing, but you take one side that covers a side of the shape, multiplied by another side that goes all the way throughout the shape. Now when you multiply these, it's going to give you that section of the inside of the shape, and because it's the inside, and it's we're working 2 dimensions here, we say it's squared. You can write out squared, or put a little 2 above whatever units, whether it be units, inches, centimeters, yards, any of that, doesn't matter. Same process for everything, just make sure you measure it the same if that's the case. Now we went over squares, rectangles, and triangles. Triangles were a little different. We had an area of the base that you're given times the height, all divided by 2. That's the only thing that's different. Square, you could just multiply throughout each side to find the area. Then we did have some examples down here showing all that. We had a right triangle, an equilateral triangle, an isosceles triangle, just to get you introduced to the idea of all these different kinds of triangles we can see out in nature. So beyond that, if you guys have any questions, feel free to leave them in the comments. Make sure you guys subscribe, and if you are watching these videos for your education or you have a kid, make sure you share those videos. We're going to continue making it, and we're going to get through geometry very fast here and then get on with some further topics. So thank you everyone for watching, and I hope you tune in next time. Bye.